At this time, it seems that the polar vortex is clearly weaker than usual due to the presence of a strong anticyclone over northern Europe, also supported by the Siberian-Russian high-pressure system, which continues relentlessly to destabilize this massive cold vortex enveloping the Arctic. The result is a fragmented polar vortex, which is expected to clearly lead to notable weather effects in the northern hemisphere in the coming weeks. Over the next 2 weeks, the polar vortex may split into 2 large chunks, thanks to the coupling of the Aleutian High and the Azores High, both supported by the Siberian-Russian high-pressure system. This split will result in a direct consequence of cold Siberian air descending in a retrograde motion towards Europe. At the same time, a large cold wave will invade North America, particularly affecting Canada and the central United States. But what will happen in Europe and Italy? The major weather prediction centers, particularly the European model ECMWF, continue to show the development of particularly harsh weather for the old continent, especially during the second 10 days of February. As Valentine's Day approaches, the cold Siberian air may have already swept through the Scandinavian countries and European Russia, causing temperatures to drop significantly below seasonal averages. These areas are already quite cold, but with the arrival of Siberian frost, temperatures could drop to below -20 degrees Celsius at flat elevations. It is possible that part of this icy mass will extend into Central Europe, the Balkans, and even the Arabian Peninsula after mid-February. For Siberian cold to reach the Mediterranean Sea, it will be necessary for a strong anticyclone to form over Central and Northern Europe, which, according to the latest trends, could strengthen this dynamic. In short, winter is certainly not over yet. In fact, during the second 10 days of February, the weather conditions could suddenly become extremely harsh in Europe and Italy.
Weather is a fascinating science that attracts the attention of enthusiasts and researchers from all over the world. Many atmospheric phenomena occur at different altitudes in the atmosphere, influencing the climate on a large scale. One of the most discussed and studied events in weather forecasting is the stratospheric polar vortex. This low-pressure system forms above the polar regions and plays a key role in the atmospheric circulation, determining temperature differences and dynamics that can have repercussions reaching as far as the mid-latitudes. What is the stratospheric polar vortex? How does the stratospheric warming phenomenon occur? How can the polar vortex split? And why can Siberian frost reach areas far from Siberia, affecting the weather in vast regions such as Europe and North America? The stratospheric polar vortex is a powerful atmospheric circulation that develops in the upper atmosphere, in the region known as the stratosphere. It is an area of stable low pressure located above the polar regions, such as the Arctic and Antarctic, which generally remains confined within a sort of fence of strong westerly winds. These winds, also known as the stratospheric jet stream, surround the polar vortex at altitudes ranging from 10 to 50 kilometers. This circulation pattern plays a crucial role in weather determination because it affects temperatures and heat flows that spread from the lower atmosphere to the upper atmosphere and vice versa. The stratospheric polar vortex remains most intense during the winter months, when the lack of solar radiation above the polar regions leads to extreme cooling. During this period, the center of low pressure tends to intensify, trapping the cold air within the Arctic or Antarctic. In winter, temperatures inside the stratospheric polar vortex can drop to as low as -80 degrees Celsius. However, this intense cold is not always confined to its original location, as under certain conditions, the polar vortex weakens and undergoes structural changes that can significantly alter weather patterns on a global scale. Many wonder how a phenomenon located tens of kilometers above the Earth's surface can affect the weather we experience every day. The key to this connection lies in the vertical interactions between the stratosphere and the troposphere, the layer in which clouds and disturbed weather systems form. When the stratospheric polar vortex is stable, it maintains a regular circulation, leading to a somewhat predictable weather system with limited fluctuation of cold air masses. On the other hand, If the polar vortex is subjected to significant disturbances, these disturbances can propagate into the troposphere, causing major changes in the configuration of high and low pressure systems across the hemisphere. One event that significantly affects the stability of the stratospheric polar vortex is stratospheric warming. This term, written precisely in uppercase letters, refers to a rapid rise in the temperature of the polar stratosphere, capable of raising temperatures by several tens of degrees within a few days. Stratospheric warming can be classified as minor or major, depending on the extent of warming and its impact on the atmospheric circulation. When a major stratospheric warming event occurs, there is a weakening of the westerly winds surrounding the polar vortex, to the point of reversing the direction of airflow.